Okay, so we're going to be going over the quiz number 4. All right, so share. Okay, the quiz number 4. Let me see, quiz number 4. Check 1. Quizzes number 4 for the solution. Okay. Okay, so can everybody see my screen?
Yeah.
Okay. So number 1, for the circuit shown, the inductor current IL is, okay, so IL is going to be going through here. So you're going to take the voltage here, divided by XL, that is what you have here, okay? And so the answer comes up to 25 milliamps. So the answer is A as an apple for number 1. Okay, for the number 2, for the circuit shown, the total current IT is, okay, now we have to find the total current. Okay, so the total current, we need to find the current that's flowing through the inductor, as well as the current to the resistor, okay? So the voltage that is going through, you do your calculation. So you're going to take IT equals the square root of the quantity IR square plus IL square, okay? So you calculate the IR, so that would be 100 volt divided by 2 kilo ohms, and that's quantity square. And this one is 100 divided by 4K times quantity square. And once you do that calculation, you should yield about 55.9 milliamp. So the answer is C as in cat for number 2. Okay, any question number 1 or 2? Okay, no question on number 1 or 2. All right, next set. Okay, number 3, for the circuit shown, the total impedance ZT. Okay, ZT. Okay, so ZT equal to the total voltage divided by total current. So we calculate the total current from the previous step. That was 55.9 milliamps. So it's going to be take 100 volt divided by 55.9 milliamps. That yield 1.79 kilo ohm. So the answer is B as in Bob for number 3. Okay, for number 4. Number 4, for the circuit shown, the phase angle theta between VT and IT is, okay, so you got the theta equals arctangent of the negative IL divided by IR, okay? So that means you have the IL, which we calculated earlier in number 1. That was 25 milliamps. And IR would be 50 milliamps. Okay, so negative 25 milliamps divided by 50 milliamps, and that's taken arctangent of that. That's come to negative 26.5 degrees. So the answer is C as in cat for number 4. So any question number 3 or 4? Okay. So number 4 is follow this phase angles right here. So it's going to be pointing toward down toward to the bottom. So therefore, that's why it's negative as an answer. All right. No question. Okay, next set. Okay, number 5, for the circuit shown, the total impedance ZT is, okay, the answer is A as an apple is 14.14 ohms, okay. So you do the calculation, ZT, it's going to be VT divided by IT, okay. So first thing I did was do the calculation was for the IT first thing. That was comes out to 1.697 amp. And so now you got VT is 24 divided by 1.697 amps. That yield 14.14 ohms. So A as an apple, number 5. Number 6, for the circuit shown, the phase angles between VT and IT is, okay, 6, theta equals arctangent of the IC divided by IR. So arctangent of the quantity 1.2 amps divided by 1.2 amps equals 45 degrees. So the answer is C as in cat for number 6. Okay, so this is your phase angles right here. So you've got your angles going to be pointing toward the positive side. So that's why we got the answer C as in cat for number 6. Okay, any question number 5 or 6? Okay, no question. Next set. Okay, for the circuit shown, the net reactant X is, okay, now we use the information. Okay, so net reactant would be just the reactant right here, XL and XC. So look like XC is going to be greater. So therefore XC minus XL is 120 ohms minus 100 ohms equal 20 ohms. So the answer is B as in Bob for number 7. Okay. Number 8, for the circuit showing the total IT of the circuit is, so you got IT equal VT divided by X net. It goes 240. So VT is 240 volt divided by 20 ohms. That yields 12 amps. So the answer is C as in cat for number 8. Okay, any question number 7 or 8? Okay, look like no question. Page down. Okay, number 9. For the circuit shown, the voltage across VL. Okay, so we can apply the voltage divider in here. So therefore, VT times XL divided by the X net. So X net be XL minus XC. So therefore, that comes up to yield to 1200 VAC. Okay. So the answer is A as in apple for number 9. Number 10, for the circuit shown, the voltage across capacitor VC is, so VC equal VT times XC divided by X net, okay? So 240 volt times 120 ohms times the quantity, divided by the quantity 120 ohms minus 100 ohms. So that yield on 1440 VAC. So the answer is C as in cat for number 10. So any question number 9 or 10? Okay, pretty silent. All right, let's go ahead and go to the next one. Okay, for number 11, for the circuit shown, the net IX of the circuit is a total current, net current. Okay, so IX, so the first thing we want to do, find the current through each of the component. So the first one was the IL, so that comes up to 30 milliamps. IC would be 40 milliamps. So I in IX equal to IC minus IX. So 40 minus 30 milliamps equals 10 milliamps. So the answer is B as in boy for number 11. For number 12, for the circuit shown, the net circuit is, okay, so therefore you have the total more, there's more current flowing to IC, so therefore it's going to be capacitive circuit. Okay, so the answer is B as in boy for number 12. Okay, any question number 11 or 12? Okay, no question. Next set. Okay, when the times 10 probe is in use in our oscilloscope screen display an AC waveform that is 10 times. Okay, so when you have something, so when you times 1, the signal would be going way above the display screen. And when you time 10, you shrink the signal down to the smaller size so you can be put on, would be able to display on your oscilloscope. So that's why the answer is A as an apple. for number 13. Number 14, an oscilloscope can directly measure AC and DC voltage, as you can see right here, like back in your first handout that was displayed to you. So this is what they showing you on the oscilloscope. They can measure DC as well as AC, okay? So the answer is A as an apple for number 14. Number 15, the maximum amplitude of an AC waveform in either polarity is the peak amplitude. So if you go to the positive side, that's V peak. To the negative side, you're going to V peak. Okay, so therefore only the peak amplitude. Answer C as in cat for number 15. Any question number 13, 14, or 15? Okay, no question. Next set. Okay, when the phase angle is measured by an oscilloscope, the reference waveform should be always used as your trigger source. Okay, right here you can use the red one to be your reference. Okay, or you can use the blue one to be your reference. And when you use that as a reference, it become your trigger source. Okay, so B as in boy for number 16. Okay, number 17. When the phase angle is measured by a oscilloscope, a lagging waveform is, okay, so say that your reference, in this case, your reference would be the blue, and lagging would be this one here, the red one. It will be shifted toward the right of the reference signal. Okay, so it's shifted to the right. So the answer is C as in cat for number 17. So any question number 16 or 17? Okay, no question, page 10. Okay, number 18, how many degrees are in 1/2 of one cycle of a sine wave? Okay, so this is one complete sine wave right here. So half of it would be right in the middle here. So it's going to represent 180 degrees. So the answer is B as in boy for number 18. Number 19, a phasor, okay? A phasor, it has magnitude and direction. As you can see, it has magnitude of ZT as well as direction of this theta. So the answer is C as in cat for number 19. Okay, any question number 18 or 19? Okay, so if most people did not answer the question number 19 because they were looking at from the website. So if you look at the website, when you can get the handout. So that was AC quiz report number 4, for example. So you click enable editing, maximize it. Okay, so when you have, okay, so this one has a 19, the 19, but in the future, if you don't see it, you have to do it, just copy this page and then just open up another worksheet on the bottom of your bottom left corner, click on that, add another sheet, control paste here, okay? And then after that, now you can add on more if you want. So you can put here and just insert more lines onto it. Therefore, you can always assign 20, 21, 22, whatever it is. Okay, so if you have a problem next time of not having enough spaces, like I said, just copy what from the original and then just paste it onto the next worksheet and make sure you put your name here and then you put your answers here. Okay, and then when you upload this, and I will look at the bottom of the sheet here at the same time too. So if I don't see anything on here, I know it probably the answers would be over here. Okay. So that's what you do if you on the next quiz, if you don't have enough room, just like I said, copy whatever from the main page and then put it into the next worksheet. Okay. So that's pretty much it. That's, I see that's what maybe many people have trouble with on the quiz. And also, most of you still have some trouble with the phase angle. You're still not really sure about the phase angle. A lot more people miss on that on phase angle than any other question on the quizzes. Okay.
Question, sir.
Yes.
On that phasor diagram
Okay.
for ZT, the direction of the arrow, that pretty much indicates the magnitude of either more positive or more negative in the direction of the arrow. Are they-
Yeah, depending on if you look at so if you look at the IC, okay, if you look at capacitor is current leading voltage. So current would be pointing upward, voltage would be pointing toward a negative. Can you see my screen?
Yes.
Okay, yeah, so yeah, if we can look at the voltage and the if you look at the voltage of IC, the voltage would be pointing down, and the pointing up would be the current. But since we only compare just the voltage wise, VR over VC, okay, that's why VC would be going to pointing down and VR pointing toward the right. And so now you show the magnitude from the beginning of R to the tip of the VC would be down here. So this would be VT, V total. Okay. And that would the angle that is pointing toward down, that would be the negative angle. You follow?
So in the diagram there where it has XC0 and R, or excuse me, XC0 and R, that's basically an XY diagram.
Yeah, this is XY. So this is Y here, this is X here. Okay.
So considering XY, so it has its negative and positive
Component, yes.
area, right there. Yeah, that's what I figured. Thank you.
Right, okay. Okay, hopefully everyone's clear on that, because I think a lot more people miss on this kind of question. I think was like number 4, number 5, number 4, which is up here. This question number 4 right here. People miss this one a lot.
Well, it's just in the interpretation of what the answer would be, how to pick up hints from what your answer is. Like say if it's negative, then you would have to assume that any line direction would have to be pointed in the negative direction. When
But you also have to remember the concept. The concept is that when you work with an inductor is the voltage leading current. So the voltage would be going positive toward this side, and current is going toward the negative side. Okay, that is from the handout from Mr. Pham went over the RL. So therefore the current of inductor is pointing downward, and the current of the resistor would point to the positive x-axis. Okay, so and then you draw the magnitude from the tip to the tip. Okay, so that would be your total IT. And this is represent your angle. Your angle is pointing toward the negative side. Okay. Yeah, you have to get a really good concept of those. Which one is leading what? In capacitor, the current lead the voltage, and then in inductor, the voltage lead the current. Okay, so the current would be the negative, the voltage would be the positive. Capacitor would be the current would be positive, and the voltage would be the negative. Okay, and then depending on what you're comparing the current or you're comparing the voltage. Okay. All right.
Thank you.
You're welcome. Okay. Any other question before we move on? Okay. So that's pretty much it. Okay. Thank you, Mr. Pham.
Thank you, Sam. Sam, can you have the new student now to install the PSPI?
Okay, certainly. Okay, share screen. Okay, so installing the PSpice. Okay, so you want to do is go into our just load onto our web, come into our website. Okay, so next thing you want to do is click on handouts. Okay, and then you want to do is scroll down to the very bottom, of the page. Okay, right here would be, okay, so you have the instruction how to install. You can look at this and follow that instruction step by step. And as well as this instruction, how to use the PSpice, okay? How to do your simulation for PSpice. You use this instruction and as well as in this instruction, okay? So example, so first thing you wanna do is open up PSpice. So you wanna do is click on it once to download the zip file. And then we'll be showing you here on the bottom left corner. So you want to do is just click on that to open it up. Okay, so now it comes in here. So you want to do is come in here and then so you want to do is you can highlight that. And then you want to do is call this one here, say extract all. Okay, so you want to click on extract all. Okay, so next thing we want to do is, okay, so extract all, and then this message pops up. Okay, so once you click on extract all, this the message extract all said file will be extracted this folder. Just go ahead and use the default mode, the default that they give you. Okay, if you want to change it, that's fine, but usually just use the default one here. Okay, and then after once that comes up, just click on extract. Okay. So that's pretty much it. And then you come back into your folder here and then you click on PSpice folder, double click on it. Okay, and then you want to do is look at the one that's stated right here, said setup. You want to set up the one said application. Okay. So you want to set up so the first one here and then the second one and so you got 1, 2, 3, and you want to do is the one in the middle. Set up the application form. So you want to do is double click on that to run it. Okay. And then the message would pop up. Do you want to allow this app from an unknown publisher to make changes to your device? Go ahead and click on yes. Okay, sorry, you can see that, but. And then once you click on yes, and then it goes through the and then it goes through the, it downloaded the whole thing. And then after that, they said, if you want to currently have many, so, okay, so request attempt to install if you do not present administration. Just click on yes, and that's fine. And then after that, this message pops up. Okay, so this message pops up. So you want to do just click on, make sure you put check mark on both of them, capture as well as schematic, and then click on next. And next, and then this one pops up. Okay, and then said please select the directory where you would like to install the product you have selected. Now I just keep at the default mode, which is here. They already put in default mode. I just go ahead and click on next. Okay. And then after that, this one pops up, and just keep on whatever it is that they recommend, just keep it. Click on next, okay. And then it pops up, okay, pop up so once that. So it pops up this one, they just confirm where they're going to install the directory is at, and then the name of the folder. That's fine, keep it, click on next. Okay, now they're copying the information into your computer. Sorry, you can't see that. I have multiple screen on mine. It keep on popping to the other screen. Okay, then there's the following file will not register because they're already associated with other application this computer. That's okay. Go ahead and click OK on that. So this was on the background. Okay. So now the installation has completed successfully. See the release notes for the last minute information about this release. Go ahead and click on finish. Okay, so they take you into the web page and they just give you a lot more information. You can click on it to read more about it. It's not necessary. You can go ahead and close it, minimize it out the way. Okay, now that it is already installed on your computer, you have to do is, so you want to do is click on your start menu on your computer, or they look like the Windows symbol. Okay. So you want to do is, let me see if I can do. Okay, so click on that. And then you want to do is scroll down to what you just loaded into your computer. So then it go PSpice. So scroll down to P for PSpice student. And you want to do just click on the arrow pointing down. And it would show you this listing of all the one that's on here. So you want to do is you can right click on this. You can pin it, or you can just take this one, drag it, and drop it onto your computer somewhere on your desktop. Okay, and that's it. And that's your PSpice. And once that is done, you have to do is just click on it, double click on it. Okay. So when you double click on it, yeah, that's where your PSpice would start running. Okay, so this is your workstation. And depending on your assignment, now you want to do is go to back into your website. Okay, so assignment, let me see, back into, so assignment number 1 would be, assignment number 8 would be this one right here. Okay, so assignment number 8. Okay, so we just have to do is just follow all the instruction here. Okay, so first thing you want to do is get all these basic components. You got a generator, you got a capacitor, you got a resistor, and you got a ground. Okay, so in order to do that, you want to do is goes up to the top menu, to the draw menu, click on it once, scroll down to say get new parts, click on it. Okay, and then here you would show, now sometimes it doesn't show this one here. If it's, sometimes it show you just this one, you can click on the advanced button. It gives you a lot more option. Okay, now it gives you a lot more. Okay, here you want to do is just time, so here number 3 instructions say generator use V sign. So you want to do is where the part name is, you type in V sign. Okay, so that's the part that we need. So that's a symbol that matches this here. So click on place to place it on your workstation. Just put it anywhere for now. Okay, so you put it there once and right click on your mouse button to exit. Okay, so now choose the next component, C for capacitor. So come up, back up the part name, type C, and that's capacitor. Place. Okay, now you put it there to exit. Right click. Okay, choose next component, resistor, place, put it there. Okay, right click. Okay, choose next component. So ground, G and D, and that's earth ground. So that doesn't look like match that, but the next one down, okay, that looks like the one. Okay, so that's all that we need. So place it and just place on your desktop. Now you can go ahead and highlight that and drag wherever you want. Okay, so now okay. Okay, so therefore, let's see, zoom to the area. Okay, so now you have this component. Okay, just like before when you have in the MSIM. So you want to do is just click on that to highlight it, to choose that component, and then you can go to edit and you can rotate or flip. Okay, so you can control R. So now rotate it. Now it's in the right direction, just like the schematic. Okay, so now I have to do it, just put it there. Now, in order to change the component, now in order to connect the circuit together, you want to do is go to draw wire. Okay, so therefore wire. Now you can connect the wire. So you want to start at the one of the lead. So go up here, click on that one time to make all the bend. So there's connected. Come to the lead of the next one. Okay, so there, click once, click here to connect, click once to start, and then we'll go here and click once, click there, click once, connected to there. Okay, and then right click to exit that mode. Okay. All right, so therefore it's there. Okay, so next thing you want to do is change the component. So change the value. So C1 is this one. So you want to do is go to that one, double click on it, and then now you can change it 0.02 UF for microfarad. Lowercase, uppercase does not matter. Okay. So next one is 6K. So you want to do is come over here, double click on that. 6K for resistant. Okay. Now for the generator, you have a lot more things to do on number 3 there. So now you click on the generator here. So now you want a generator, and so we have to do it. Just click on the one that we need to set up. So V off. Choose that V off, and then come up here, type in the 0 value. You can press enter or you can press save attribute. Okay, so either one would be fine. So now you got the next one. V amplitude is 14.14 volt. Okay, press that. Like I said, you can press enter or you can press save attribute. Okay, the next one is frequency 1K. So 1K. Click save attribute. Okay, so next scroll down. Okay, so and then all the way to the bottom is PKG reference, and we want to change that to the word generator. Okay, so click on save, click on OK to save that, and that's pretty much it. And now we have all the parts in place. Now next label, we have to put V in and V out. Type, in order to do that, you want to do is highlight that wire, double click on that wire, and you want to do is put a label on it. Okay, like I said, double click on the wire and then put a and then type in the label. Okay, so that's pretty much step number 3. Okay, so step number 4 to do the setup. Okay, so next thing you want to do is the setup. Okay, step 4 and step 5. So step 4, so you're going up to the analysis menu, scroll down to setup. Okay, so click on that. It would bring up this setup menu, and you want to do is you want to click on the word transit. So transit is this one right here. Okay, and here, so here it's at the final time 2 microseconds. So you want to do 2 millisecond. 2M will be fine. Okay. So you can do the print step also if you want, but it's not necessary. So click on OK. All right. So that is done. So 2 microseconds. Then click on OK. We just did that. And click on exit to exit. Okay. So that's exit that. Okay. Next thing you want to do before you start your simulation, you want to save this file. Okay, so you want to do is click on File, Save As. Okay, now you want to do is save somewhere on your in your folder. Now I already called mine called PSpice, so I'm going to save it there. So this is assignment 8. So assignment 8. So this is the RC circuit. Okay. So something similar, something like that. So you so you know what it is. Okay, so and then click on save. Okay, so once that is saved, now you can go and click on the, now we can ready to run it. So go to analysis. So this is with step 6, analysis, simulate. Okay, now it's running. Okay, so it's running. Now you want to get, if it's everything is correct, you will get a black screen. So that means it's you did it right. Okay, if you get a gray screen, that means you did something incorrect. So you want to do is go back into your schematic and redraw this schematic. Okay, I'll start it new. You can click on here, click on new to open up a new one. Okay, but mine is working just fine, so therefore we're going to run that. Okay, so now you got this command. Then after that, just follow just like what we did before in MSIM, so collecting the data. So first thing is generator, so therefore you want to do is setting up those information. So first thing you want to do is come in here, called trace. You click on once, click on say add trace. And then you want to do is get rid of all these other options. We don't need the alias name. Okay, so generator would be right here. So therefore it's so this is the same thing as VN. So therefore VVN, okay, so voltage of the VN, click OK. And that is your schematic, okay. So you can use this here to, so you can choose this one to add, you can use this graphical methods to put your your trace on, or you can always use the menu here on top. Okay. So next thing you want to do is click on that, and then next cursor. Now my cursor is not working like the one that it should be on my other computer, so I'm sorry that it doesn't show you the right way. But you can put the cursor and you can choose these, let's say these options here. So therefore right there would be my maximum voltage. So V peak. So you want to do is just look at that V peak. So therefore I can click on that. Now I'm going to use this option here, show you exactly the voltage. Okay, so 14.036. So right here would be my voltage. Okay. Now yours might be show you different option that would show you just like the one that Mr. Pham gave you a hint on. Okay, yours, once you click on the cursor, it would be something like this. This little menu right here would pop up, and then you have to do it, just move your probe. So you can move it by moving on here. You can use the arrow key on your keyboard, or you can use your mouse to navigate to look at the voltage at different location and different frequency at different location at different time. Okay. But mine is only at this point. So therefore now I just have to do it, just come in here and type in my answer. So VN was 14.36. So that is just the peak. So I had to double that. So this will be equal to 2 times the 14.036. Okay. So that's what you do. You have to do it. Just go ahead and collect your data and complete this circuit, this handout. So next thing you want to do is, now that you're done with that one, so therefore I don't need this one anymore. So next thing you want to do is find VC. Okay, so VC would be right here. It's between V out and V in. Okay, so back into trace, add trace. Now it's going to be V in minus the V out would give you the VC. So V out, or so you want to do so V in first, minus sign of V out, and click OK, and that should be your circuit. Okay. And then after that, just put on your schematic again, your cursor, and then just look at whatever your circuit is. So I'm going not to use that one. I'm just use this one here. So right there would be my point. Okay, so that's 11.23. Okay. So right here, so that is from the reference point, which is at 0 to this point. So therefore, I had to double that because they want peak to peak. So this one is 2 times 11.232. Okay. So that is one way. And the other way is one side, you can do right click. One is left click on this one. You can do two of them at the same time. Okay. So you can do as you now this one is a little bit out of range. Let me go ahead and do a right click over here. Okay, so this one is negative 11.18. So I can take this 11.232 plus the 11.12. That will give me the VC. Okay. So that's what you're going to do. Either right click, you can do a left click one time for your reference point, and you right click for your next point. Okay, it's just almost like your cursor on your oscilloscope in the classroom. You put cursor number 1, so you can put a left click here, and a cursor number 2, you'll be in this case you use a right click on your mouse. Okay, so over here will be your number 2. Okay, so that's how you do it. You use your like I said, yeah, that's how you do it. Just everything is inside your trace. Once you're done, delete it and then go ahead and do the next one. Okay, so hopefully everybody can follow. I didn't go too fast. Any question? Okay, well, back to you, Mr. Pham.
Okay, thank you, sir.
You're welcome. Thank you.
Okay, so before we started, make sure to download the handout number 6 for the complex number and number 7. So you get any question to me, okay? Otherwise, I have to adding using my iPad. Okay, so we already done for RCL circuit. The important thing is you have to make sure for RC circuitry, then the current IC will be leading VC 90 degrees. And also for RL circuit, VL leading IL 90 degrees. And VRIR, they will be in phase. Okay? That's very important. Another thing, the VD and IT, they're not in phase. They're not leading or lagging 90 degrees. So that's why normally you have to calculate the phase angle. Get the phase difference between total voltage and the total current. And also, the other thing, when you get a RCL circuit, you cannot solving the problem with both L and C. You have to come up with a new circuitry. They can be either RL or RC circuitry. Okay? That is a very basic, we already done. Today we get another thing. We'll be talking about complex number. Now another way to solving the RCL circuitry using the complex number. For the complex number, then you don't have to memorize IC leading VC or IL leading IL. They will be shown you. Okay? Either way you want to do. The one we already done, or the new one we'll be learning today. So first thing, a complex number. Here, number of the form C equal A plus JB. That's just a formula. Okay? Where A and B are the real number. And J, by definition, equal square root of -1. And you understand we cannot get any square root of negative number. Square root have to be of the positive number. However, J equals square root of -1. Definition. The number A equals the real part of C. B equals imaginary part. Okay? That basically you must know. A is just a real. However, B equals imaginary. Okay, in circuit theory, J used to denote the imaginary component rather than I to avoid confusion with the current I. Okay, geometrical representation. Complex number may be represented geometrically, either in rectangular form or in polar form. At point on a 2D dimensional plane called complex plane. The complex number C equals 6 plus J8. That's what the complex number. Represent the point was coordinate on the real axis is 6. That will be the real. That's what we call imaginary. Okay? Remember, this is the real axis and this will be imaginary axis, stand for J. So this is the value of 8, but 8J. So that's why they plot 8J. Okay. C equals 6 plus J8 represent a point was coordinate on the real axis is 6 and was coordinate on the imaginary axis is 8. This form of representation equal a rectangular form. Okay, so if you get any point in here, and you can see if the point in here will be 6 plus J4. Okay, so any question on this part here? Anything confusing, just let me know. If it's not, let's see, what next? Complex number maybe also be represented in the polar form by magnitude and the angle. Okay, you get a C equal 10, angle 53.13 degrees. Here, complex number with magnitude is 10 and angle will be 53.13. Okay, so now you can see the point C right here. Okay, the amplitude here will be 10 and the angle will be 53.13. That will be a polar form. Okay, C equals C angle. Theta polar form, where C is the magnitude of C from the geometry of the triangle. And now if you want to calculate the C, then C equals square root of A square plus B square. Now if you connect that one here, that will be B and that will be C. Sorry. So that's normally using the Pythagoras. You can get C equals square root A square plus B square. And also you can calculate the tan arctan by of the angle. Okay, equal B divided to A. That in trigonometry. However, to you, only thing that you have to memorize how to calculate the angle. Okay, theta equal arctan of B divided to A. And this they call a complex number in the polar form. So you get a complex number, okay, in a rectangular form. Okay, and now you can get complex number in the polar form. Okay, any question? If you go to the college university, normally you will be using this way. Okay, more math. Like one example. They said determine rectangular and polar form for the complex number CDV. C here, okay, D here, and V here. Okay, W here. Of the figure so. Okay, remember A equals C cosine of theta, and B equals C sine of theta. Okay, and C equals square root A square plus B square. That the angle equals arctan minus arctan B over A. So first thing they given you example. Part C first. That means in here, the real will be number 4. J will be number 3. Okay? That's what they tell you. Real part 4, imaginary part 3. So that's why you can get C equal 4 plus J3. Okay? That's for rectangular. in polar, then first thing you need to calculate the C. C equals square root of 4 square plus 3 square. You get a 5. And the phase equal arctan 3/4, you get 36.87. So the C in polar will be 5 angle 36.87. Can you follow it? Okay, if you understand, you can tell me, you can calculate for me W. We already did it for you point C. Now I want to do for point W. Both in rectangular and in the polar. So the first thing to do it for me, for point W in rectangular. Who can give it to me the answer?
Hey, Mr. Pham, let me try this one. Hello?
Yeah, go ahead.
Okay, so let's see here. Let's go C equal W, would that be -4, and then it's plus J -4. Or is it, if it's going down, does it have to be minus J4? Okay, once again.
You mean a minus J4.
Okay.
You're talking about which point?
C, okay.
You're talking about C.
Right. C equal minus J.
What do you mean C equal minus J?
Well, the first part.
First part, you have to tell me what the real for point C, what the imaginary for point C.
-4.
How come you get -4?
Because
They're already telling you.
You telling me do the one for W, right?
No, that's what I asking you. You're working on W.
Correct.
Okay, so basically the real part will be -4.
Right, that's what I said, -4.
Yeah, imaginary.
And then you have to say what, plus or minus J4, -4?
Okay, I asked you imaginary part of W.
So it's -4 minus 4J.
Okay, try to separate it. You're talking about W.
Mhm,
We said the real part will be -4.
correctly.
I
Correct.
agree. Another imaginary part for W is what?
Oh, -4 plus J4.
Perfect. J4 is the
Thanks, Kevin.
imaginary of the W. So that is the C or W in rectangular. Now, in the polar, you need to calculate the W. value equal square root.
Hey, Mr. Pham, can I, just before you go to that, can I just ask something?
Go ahead.
The reason why I initially was saying -4 is because you got -4, and then you got a 4 that's going down on the y-axis. The -4 on the y-axis.
You can see right here, W. You want imaginary. That number 4. That means J4. You want the real. You going down. You get -4.
Okay. So, yeah, I'm looking at the wrong one. The -4, that's for D, not for W. I see what it is now. It's -4 plus J4 because W intersects the +4 on the y-axis, and it intersects the -4 on the negative x-axis. I see. Okay, I got it.
Okay, so that is just the form in the rectangular
Right.
complex number. Now we want the complex number in the polar. In the polar, you have to calculate the value of W.
Right, so you got to take the square root of those two numbers, right?
Right. This is the answer for when W. Rectangular -4 plus J4.
Right, correct.
Polar will be 5.66, angle 135 degrees.
Hey, Mr. Pham, and on, I noticed, well, the angle, initially it comes out a minus angle, but you want a positive angle, correct?
Now the thing angle will be go from here. Okay.
Yeah.
So basically, that is -45. The total will be 180 degrees.
Right.
So that's why.
So it's 180 minus 45.
Exactly. Okay. Go ahead, do for me number D. The thing is, you have to understand this thing. In order to understand more, this is not a simple, a little more complex, okay, due to the complex number. For the
So then D would be 4 minus J4.
perfect.
Okay, yeah. That's what I got screwed up on before. Okay, 4 minus J4.
That will be a complex number in a rectangular.
Right.
And now I want it in polar. Let's see, D.
So you got to do the same thing, square root them.
Yes, I want to get the answer. D here. So D for the rectangular, 4 minus J4. For the polar, then you get the amplitude 5 and the phase angle minus 45. So D will be 5.66 angle minus 45 degrees. Okay, last one. When V, right here.
So that's 0 minus J2. Let me see that again.
They don't have a real on the when V.
Was V above or below the x-axis? Oh, it was below. So if it's below, can you say it like this, Mr. Pham? Can you say 0 minus J2?
Yeah,
You can say it that way?
yeah, but the thing is, 0 means nothing.
I know, but I was just using the form that you originally showed us.
That's a little confusing. Basically, that's a minus J2.
Yeah, that's what I was saying. On your answer, it looked like they just got J2, but since V is below the x-axis, then it should be minus J2. Is that correct?
Right.
So
That's from the book.
right.
So basically, I think this way.
So where it says VJ2, it should be
Okay, that will be minus,
J2. Yeah, exactly.
and that will be V will be what?
So that'll be minus 90 degrees or 270 degrees or 2 minus 90.
Okay, now power of J. Power of J are frequently required in calculation. Here are some useful power. J square. That means to take a square root minus 1 times square root minus 1, you get minus 1. You just take a square root out. J3. That means J2 times J. J2 is minus 1 times J. J is square root. Let's see. J equals square root of minus 1. So J3 equals J square. That means minus 1 times J is minus J. J4 means J2 times J2. So minus 1 times minus 1, you get a 1. Minus J times J. Okay. J times J is J square. Minus J square equals 1. J square equals minus 1. Okay. Minus 1, you get a 1. Another thing. 1 over J. 1 over J times J over J equals J divided to J square. J square is minus 1. Okay? J divided minus 1. You get minus J. That's just a few things they given to you. You see how J working. Example. Given A equal to plus J1 and B 1 plus J3. That's just a complex number. They want to know the sum and the difference. That means they want to get the A plus B and A minus B. Solution. A plus B. Okay. For the complex number, when you add it, you take real adding to real. 2 plus 1 equals 3. J1 and J3. Okay. You adding J, you get a J4. Okay. And now you get a subtraction. A minus B. Same thing. Real minus real. You get 1. The difference between J1 and J3 is minus J2. So remember, if you're working with the complex number, if you're adding and subtraction, you have to follow that way to do it. Okay. The next one. Multiplication and a division for the complex number. They given you example. A triangle 35 degrees and B angle Q minus 20 degrees. They want to know A times B and A divided to B. So multiplication and division, they using the polar. 3 angle 35. Multiply to the B, 2 angle minus 20 degrees. First thing what you need to do, times the real. 3 times 2, you get 6. Okay. The angle will be the difference between two angles. That's what they gave it to you here. Okay. you adding the phase. A times B, and the phase will be adding up. Okay, so 35 degrees adding to 20 degrees, you get 15 degrees. If you want to multiply, and the difference for the divided, you take the real number to divide it. 3 divided 2, you get 1.5. However, the angle will be different. This is the formula. A divided to B. The angle will be A minus B. That's what you get. 1.5 angle 55 degrees. Finally,
Mr. Pham, just so we got that right. In the answer, it says 35 minus 20. And the minus times the minus is a plus. So that's why you add them together.
55.
Yeah, but my point was, it's got dash, which is minus.
Right. So 35, you're adding 20. Minus, you get to add it. Look. Okay, finally, you add or subtract using rectangular form. You multiply and divide using polar. You have to follow that rule. Whenever you want to adding or subtract the complex number, they must be in rectangular form. However, multiply or divide, they must be using polar. Any question? Oh, okay. Now you can try for me. Convert the following to polar. A J6, B minus J4, C, D, E, F, G. Okay. Try the best you can. I don't have any answer. We need to do it. This will be using all the time. If you want to using the complex number to solving for RCL circuit. So the first thing, who get for me?
It's gonna be 6 positive 90 degrees.
Correct. B.
It's gonna be 4 minus 90 degrees.
Three plus J3. The reason I want you to get the calculation, for someone they not cannot following right away when they watch the video. Hopefully, we'll help them understand. Normally, if you want to working on that one, you need to get C square root, right?
Right,
3 square.
3 squared.
And the phase. Three over 3, right?
It's 1. That would be 90 degrees. So 3 times 2 is 9, 3 times 2 is 9, 9 and 9 is 18. So it's the square root of 18. And then 3 over 3 is 1.
Four point two.
Oh, yeah. 45. Is that what, 45 degrees? $45.
So that will be 4.2.
Or 4.24, the same thing. Four point,
Who done for number D?
D, 7.2,
7.2 angle.
negative 56.3. Negative.
Negative. Sorry. $56, right?
Yes, sir.
0.3.
0.3.
Number C. Try to get it done quick. I put them here, 1C. Is it 10.9? What angle?
$122.
What you get?
Positive 122.
You say 122.
Yes, sir.
Anyone get the same answer?
I missed that. Which one was that?
Number C.
Number C, okay.
No, number
E.
E. Sorry.
So E, the magnitude comes to 9.4 at 122 degrees.
You're talking about number E, right?
Yes, the magnitude is 9.4 at 122
How,
degrees.
how can you get a magnitude?
You take the -5, square that, and then
Plus.
square the 8,
And,
and take a square root of, and then add those together, and then
okay, that
and
means
then take the square
25.
root. Yeah, so 25 and then
64.
and 64.
And take the square root.
Yes,
Okay, 9.4, correct?
25 and 64 is 89. You take the square root of 89.
That's correct answer.
Yeah, square root of 89 is 9.43. Yeah.
Now, F.
Two point two.
2.2.
Yes, sir. Negative 63.4.
So basically, I want any way I can verify number. F will be 2.2. Angle minus 63.4.
looks good.
Okay, G. Is it 3.6?
Correct.
Angle.
negative 123 degrees.
You say minus 123.
Yes.
Okay, so we go to A. They want to converting polar to rectangular.
There's gonna be J4.
Sounds good.
To B.
That's 3. 3.
Sounds good.
To C.
Negative J2.
Sounds good.
Okay, to D.
.83 plus J plus J 3.21.
Adding what? Plot, right?
J 3.21.
J,
3.21.
who get the same on D?
Sounds good.
Number 2E. If you want to converting polar to rectangular, remember we get up here. That is for the polar, okay? And in order to calculate the rectangular, you need to calculate A, C cosine theta, and B, C sine theta. That's how you can get the answer. Who get E?
-3 plus J 5.2.
Can you repeat again? Repeat for me.
-3,
You mean
-3
-3.
plus J 5.2.
Who get the same?
Looks good.
Okay. QF. What you get for F?
$2.35.
What the real number?
2.35.
You get 2.35.
Yes, sir.
The real, you get 2.35. Then what? Night.
Minus J 0.85.
Say what?
0.85.
You get the same answer.
That's pretty good.
Okay, 2F and last one, 2G.
Negative 1.64 minus J 0.6.
Okay, so make sure you have to re-exercise, do it over and over and over. The thinking later on, you have to do it all the time. You get polar, then you have to convert into rectangular. Or you get rectangular, you have to convert into polar. Remember, if you were to adding or subtraction, then the form must be in the rectangular. And if you want to multiply or divide it, then they must be in the polar. Okay, any question up to this point? If it's not, we will be stop in here. We'll be continuing tomorrow. Also, in tomorrow, I try to see I can try to help the new student how to working with the generator and the digital scope. Okay. So you get any question? Okay, and also I get that some is not a good news to the program.
Oh,
That means the dean said for next semester, if you already get this certificate, then you cannot register anymore into this program.
wow.
I don't know yet. I will be trying to thinking and will be talk to the dean to see what's going on. This is to me, this is a continuing education. How come they can limit the people they already get certificate and they cannot be enrolled into the program? What is the difference?
Everything comes down to money and politics.
I don't know, but they have to answer me. Just let me know what the policy for continuing education when they not allow the people already complete the program, and later on, they cannot register into the program again. The thing they did is a technical granting. They will be very changing up to the date. So the people done last year, last couple of years, and now everything will be changing. How come they want to learn it and they cannot be get in? They have to answer to me, telling me, is it that the policy from the dean or the policy from the continuing education? If he not make it clear, then I will be asked to meet the lady, new president of the program. I want to make it clear. That's it. I can follow, no big deal.
And Mr. Pham, they need to do that in a timely manner so that people who already have their certificate can make a decision on what they're going to do, like register in another curriculum or do something different.
What do you mean do something different?
No, you didn't hear what I said. I'm saying you need to find that information out in a timely manner because August and September will be coming around pretty fast. So that students will be able to make a decision on what they're going to do if they don't let them come back.
Only the people, what they said, already get the certificate. If you not get the certificate ready already, yeah, you can be in the program, no problem. But the one I not agree, support anyone, no matter what, they can be registered if they want to learn more. You understand it's a big thing. This is the continuing education. The level in the program, not the same. Very, very tough to run this program. But anyway, we'll see. Okay, so you get any question to me? If it's not, good night, everyone.
Good night.
You sir.
Okay, good night.